Hello students, in this video we will be looking at theorem 8.1 under properties of a parallelogram, which says that a diagonal of a parallelogram divides the parallelogram into two congruent triangles. Let us begin with a figure. We have been given that quadrilateral ABCD is a parallelogram and AC is the diagonal. We have to prove triangle ABC is congruent to triangle CDA. So let us begin solving. In triangle ABC and triangle CDA. In triangle ABC and CDA, what do we have common? AC is common side. AC equal to AC, put as common side. What else do we have? We have been given triangle ABCD is a quadrilateral ABCD is a parallelogram, which means that AB should be equal to DC and AD should be equal to BC. So we'll write over here AB equal to CD and we have AD or rather BC, we'll write BC equal to DA. Okay, and why these are equal? Because these are opposite sides of a parallelogram. Now we've got all three sides equal to each other, and hence we can say therefore triangle ABC is congruent to triangle CDA by triple S congruence rule. And that is all that we needed to prove, because as per our theorem, the theorem is something that gives us a definite statement that we can use or apply while solving various proofs. And here it says that a diagonal of a parallelogram. So remember, in a parallelogram, always the diagonals of a parallelogram divide the parallelogram into congruent triangles. So we have been given only one diagonal AC. If it was BD, then it would have made two triangles, and those two triangles would also have been congruent to each other. So remember, in a parallelogram, so these are part of properties of a parallelogram, that a diagonal of a parallelogram divides the parallelogram into two congruent triangles. So with this we have proved theorem 8.1. If you have liked the video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive notifications whenever new video is posted. Thanks for watching. See you in the next video.